Hi guys, I just want you guys to watch this video to have an idea. Now we're going to go over this, like don't worry about trying to write all this down. I've got these notes for you to give to you on the next class, but I just wanted you to kind of watch this because I'll go through parts of this pretty quickly in our next lesson, and I want you to be familiar with how you decompose these fractions. Okay, so if I'm looking at partial fractions, back when you took algebra, you took calculus or whatever, you learned how to add and subtract fractions, rational expressions. And we had to get the common denominator and put them together. So what we're going to do is take that idea of now, if we have something we can't integrate, we're going to see, all right, well, could I reverse that process? Could I start with the answer and go back and separate it into fractions? Because if this was, whatever, the negative one here and the one here, those expressions are really easy to integrate. And so that's what we're working on is getting, using this partial fractions decomposition, so going backwards, and then being able to get something that you can integrate. We'll do all the integration next time. I just want to practice how do you undo those fractions, okay? So partial fraction decomposition. So that's, again, we're going to take the answer, and we're going to go back and break it into the two fractions. All right. So you've got to look at what the factors on the bottom look like. So if they're distinct linear factors, okay, meaning they are different. Linear, we know x to the first power is linear, okay, and they're all different. You're going to set them up just like this, a over whatever the factor is, and you might have a b over the factor. You keep going, all right? And then we're going to look at one of them that has repeated linear factors, where we've got you've got x plus 3 squared. You got two of them. And so we'll look to go like that. And then in our next class period, we'll also go over what if you have quadratic factors, because that's a whole different ballgame. All right. Okay, so your steps. First step, factor the denominator, denominators. You're going to rewrite with your a's and b's and c's and d's, whatever it is you need, okay? Multiply each side by the common denominator. Then you're going to plug in the numbers that make each denominator, each factor equal 0, and that's the way you can solve for a and b. All right, so those steps might not make sense right now, but let's go through an example. All right, so give the partial fraction decomposition for the following. All right, so we're just going to do two quick examples, and we'll do several more next class. Just want you to have an idea. All right, so you start and say, got 6 over x squared minus 2x minus 8. Now, there's no integral. We're not doing anything. We're just undoing the fractions. Go and say, hey, what must have added together to get that? So you factor. So I can factor it to a -4 and a +2. All right. So then look at what you got. Well, these are both linear factors. X is to the first power, and they're different. Okay. So I'm going to set it up as a over one of them and b over the other. Okay. Doesn't matter which one. You could have a over x plus 2 and then b over x minus 4. We get the same answer in the end. Okay. But that's how you're going to set it up. All right. So now, once you get it all set up with your a's and b's, you're going to multiply everybody by the common denominator. The common denominator is always going to be whatever was you started with on the bottom. So everybody gets an x minus a 4 and an x plus a 2. So then cancel out, and let's write what we got now. So we have 6 is equal to a times x plus 2 plus b times x minus 4. Okay, so now our goal is to solve for what's a, what's b, okay? So you're going to look at your factors and you're going to say, all right, what would it take for that factor to equal 0? And that's what you're going to let x be. So one time if I look at this first factor, x plus 2, I'm going to let x be -2. Set that equal to 0 and let x be that. If you set x minus 4 equal to 0, then x is 4. All right, so first time I'm going to let x be -2. And when I do that, you can see what happens in that first parentheses, okay, where it's gone because it's a times 0, so 6 is equal to -6b, and so we know b is -1. All right, do the same thing, but now you're going to let x be 4. And again, when by letting x be 4, then this one zeroes out, and I can solve for a. So 6 is equal to 6a, and a is 1. So I know that this partial fraction decomposition, so we got a is 1. It's 1 over x minus 4 plus, and we got b was negative 1 over x plus 2. So I didn't have to integrate that, but if I did, now those are two really easy expressions to integrate. Both of them are just natural logs. You would do that u substitution to get 1 over u, and then you can integrate it pretty quickly. Okay. All right, so that's where if your factors are linear and they're different. Let's look at one with repeated linear factors, and we'll save the quadratic factors for the next time. All right, so I got 2x squared minus 25x minus 33 over, all right, I got x plus 1 squared, so I got two of those times x minus 5. All right, so when you have repeated linear factors, what you have to do is you have to see how many you have. I have two of them, so then I'm going to make two fractions from just that piece. You're going to do a over this one to the first power, and then you're going to do b over it to the second. You have to keep going up until you have that many. So if I had 4 of them, I'd have to do a over 1 of them, b over 2 of them, c over 3 of them, and d over that parenthesis to the 4th power. I should be saying to the 2nd power, to the 3rd power, to the 4th power. And then this one, I have c over x minus 5. Okay? All right, so multiply again by the common denominator, which is just the denominator that you have, that you came with. All right, so then that x minus 5 cancels, x plus 1 squared cancels, and just one of those cancels, and then everything over there. Okay, so I'm left with 2x squared minus 25x minus 33. All right, a times x plus 1, x minus 5. B times x minus 5. C times x plus 1 squared. All right, so my goal is to figure out, all right, what were a, b, and c to be able to add them together and get that fraction. All right, so again, look at what would make those factors disappear. You would let x be negative 1 and then let x be 5. All right, so let's do negative 1. All right, so if you let x be negative 1, then that one goes away. Like a is going to zero out because that middle term is 0. That middle factor is 0. C is also going to zero out, so all I have is b, all right, times negative 1. Negative 1 minus 5. All right, if you do that math out, you should get negative 6 equals negative 6b, so we know b is 1. All right. Then let's let x be 5. So plug in the 5. All right, so if I look at it, if I let x be the 5, then a still going to zero out. B is going to zero out because I get the 0 in that parenthesis, but I've got the c times 5 plus 1 squared. So something equals 36c, and if you do that side out, you should get a negative 108. And when you divide both sides by 36, you get c is negative 3. Okay? So now we're kind of stuck because I know what b is and I know what c is, but I still need a, and I've let x be the two values that it can be. So when you run into this situation, if it's something like this, it's pretty easy. You can just pick any other number for x to plug in besides 1 and negative 3 and use that number, that value, plus b is 1 and c is negative 3, and you can plug it in, which is what we're about to do. Sometimes if you have bigger problems than this, what you have to do is something called equating the coefficients, which we'll do in a lesson. All right, so since I've used negative 1 and since I've used 5, what I'm going to do is this. I'm going to say, all right, let x be 0, okay? And then I'm going to use b as 1, and I'm going to use c as negative 3. And I'm going to plug all those in, and then I'll be able to solve for a. So if I let x be 0, I get a times, all right, so again, I'm letting x be 0, so I get 1 and negative 5. I'm letting b be what I found, which was 1, times x is 0 in that parenthesis, so negative 5, plus c is a negative 3 times, I'm letting x be 0, so 1 squared. Okay, so I can do this math out and get whatever a is. So the only thing over here is negative 33, and I get a negative 5a, a minus 5, minus 3. So negative 33 is equal to negative 5a minus 8. Add 8, negative 25 equals negative 5a, and I get a is 5. So the partial fraction decomposition for this one would be 5 over x plus 1 plus 1 over x plus 1 squared plus a negative 3 over x minus 5. Okay. All right. Like I said, we'll do definitely more of this and go over this, but I wanted y'all to be able to follow me when I start this for the next class. All right. Thanks. Y'all have a good weekend.